Today we're learning about how to graph a quadratic function. The first question asks us to find the leading term. We can only determine the leading term if our function is in descending order. Our function is in descending order because it has our highest term or degree first, and then it goes down to the constant. So our leading term would be the term in which has the highest exponent, and in this case it's the x squared. And typically, again, if you're putting this in descending order, then your leading term is that first term. It's leading. All right, the degree for this is 2. That's your exponent. And I just want to make a note that our leading term is positive. So if our leading term is positive, then that means let's change this. The right side is going to go to infinity, and our left side is going to also go to infinity. So if we want to show what this looks like kind of on a graph, let's say this is our graph, then we know that on the right hand side, because it's positive, then this side's going up, and because it's even, the left side's doing the same thing, so this is also going up. And we know it's a parabola, right? So if it's a parabola, because it's x squared, if it's positive, both of those are going up, and we know this shape will eventually be a parabola or that typical U shape. Okay? So does the parabola open up or down? So this is going to be opening up because we have a positive leading term. So this is going to be an upward facing parabola. Does it have a maximum or minimum? That's going to be determined by this bottom point or top point, depending on which way it's facing. Since this is facing up, we have a bottom point, which is a minimum point. That is the minimum point on the graph. So this is going to be a min. And then it asks to find the vertex. So there are a few different ways to find the vertex. I am going to use the formula x equals negative b over 2a to find the vertex. Now this comes from the general form of a quadratic, ax squared plus bx plus c. So this is coming from the coefficients here, where a is 1 in this problem and b is negative 8 in this problem. We're not worried about c right now, but we'll come back to that. All right, let's plug in. So be very careful when you plug in. You've got a negative from our formula for the vertex, the x value of the vertex, but our b is also negative. So we've got a negative here and then parentheses negative 8. All over 2 and a, we've got a 1 there. So this is going to be 8 over 2, which is just 4. That's giving us our x value of the vertex. Now how do we find the y value if you know the x value? Well, just like you would do for anything else, you're just going to plug that in. So we're going to plug the 4 into the function to find the function value, the y value of this point. So this is going to be 4 squared minus 8 times 4 plus 12. I'm putting parentheses around this. It's not necessary with a positive number, but I do it anyway just to get in the habit of doing it, especially if you're plugging in negative numbers. Okay, so we've got 16 minus 8 times 4 plus 12. So we get negative 4. And now we need the vertex as a point. So this is going to be the ordered pair, 4 for your x value, negative 4 for the y value. Now if I wanted to graph this, that's just one point on the graph. I don't know how wide this parabola is. I don't know any other points on the parabola. So what we want to do is find some other points. So let's do a couple different points. Let's say that our vertex is 4, negative 4, and we want to find a point 1 unit to the left and 1 unit to the right. We want to know what's happening around the vertex. So let's find f of 3. That would be 1 unit to the left. If I have 4 as the x value, 1 unit less would be 3. And then we're also going to find 1 unit higher, bigger, greater. So 4 plus 1 would give me 5. So we want to know what happens around this vertex. Okay, we're plugging it again back into our original function. So this is going to be 3 squared minus 8 times 3 plus 12. And this will be 5 squared minus 8 times 5 plus 12. So let's see what we get out. So we have -3 here. And we also have -3 here. Now this is actually what should happen, and the reason is because this is a parabola, so if you go over one and up and then over the other way and up, those should be hitting at the same y value because the parabola is symmetric. It's symmetric. So we'll see that in a minute when we graph it. All right, let's look. We have other points that are x value 3, y value -3, x value 5, and y value -3. Okay, let's graph these points on our graph now. So we're going to plot the vertex and both of the other points and draw this as a curve. So 4, -4 was our vertex. 3, -3 is one point, and then 5, -3 is the other. Now I can actually plot any point on this graph, but at a certain point it's going to be too high. So for example, if I ended up picking maybe, let's say, -5, I would probably get a point that's not even on the graph. So you want to stay around the vertex so that you're actually going to be able to graph this, especially if you're graphing it by hand. But even if you're graphing it using a computer, often you need a point that is plottable. Okay, so this is a curve, so we're going to make it a U shape. And we could make this more accurate, but this is good enough for now. You can make it more accurate by picking more points. All right, so we have our U-shaped parabola. Now it's asking for G part, what is the maximum or minimum value? So you told me, and we decided that this was a minimum here for the vertex, but the minimum value is the Y value, as in how high or low does it go? What is that point? What is that value? So in this one, our minimum value is -4. That's the Y value of the vertex. Now, remember I talked about symmetry, that this has it's symmetric. One side and the other side are the same. So there's a line that we can draw here down through the middle of this parabola that there's a few different ways to think about this, but if we were to fold our paper on this parabola, they would lie on top of each other. Or you can think of it as this line is cutting the parabola in half, and each half looks the same. Okay, now we need to actually talk about what is the axis of symmetry. Well, it's a line, so it needs to be in line format when we write this. If it's a vertical line, that's an x equal. So this is going to be x equal. And then what is our x value of this line? Well, the x value of this line is 4. So when we have the axis of symmetry, we must write it as a line, x equal 4. The whole thing, not just 4, x equal 4. Okay? What is the range of the function? Range has to do with y values. What is the lowest y value up to the highest y value? Our lowest y value in this problem is -4 because that was our minimum. So we're going to start with -4. We're actually going to include that in our interval, so we need a bracket there with the -4. And then how far up does this graph go? Well, it's going up on both sides forever and ever. So in mathematics, that means infinity. And we're going to put a parentheses there with infinity. Again, you're only using the bracket if you're going to include the number. You're using a parentheses if there's no particular number to include or that particular number is not included for whatever reason. All right, increasing and decreasing. Increasing is where the function is going up from left to right, and these have to do with x values. So our x values here, let's see. So if I start on the left side of this graph, it's going to come down. That's decreasing. So it's going down, but when it hits this point, it starts going back up. So this point, from this point onward, is increasing. We need to write this, though, in interval notation with x values. So what is the x value of this point? The x value is 4. So we're going to start with 4. And then how far to the right does it go? How far to the right does it go? Well, it does end up going on and on forever. So that's your infinity. And that's going to get a parentheses. Now, increasing and decreasing, the number that we put here is also going to have a parentheses because at that point, that is where it's changing. It's changing from decreasing to increasing. So we're just saying that at that point, it's doing neither. So we're not going to include the 4 in this interval. Where's the function decreasing? So where's it going down? So it starts up here and it goes down to this point. So again, I need to think about this. This is not y value. So even though we're starting up here, I'm not looking for this to go positive infinity. What is happening with the x values? What's happening with the x values? So the x values are going further and further and further and further and further left. So if I was to continue with this graph, it would keep going to the left more and more. So that's going to be infinity, but in the negative direction because it's going left. And that's going to be a parentheses. And again, it comes down to that point. X value is 4. So again, range has to do with y values. Increasing and decreasing has to do with x values. So that's how you would graph a parabola and determine the properties of it.